Welcome everybody to our next example on polar coordinates. So again, here in this problem, we are asked to find the arc length on the interval from 0 to pi for the curve defined by r is equal to cosine squared. So let's see if we can define a definite integral that will represent this arc length. So again, kind of coming back, we remember that our change of coordinates for polar form was given by x is equal to r cosine and y was equal to r sine. So that for our function r is equal to cosine squared, we then have cosine cubed of theta for x, and we have cosine squared theta sine theta for y. So that now we can compute our arc length form. So our arc length form ds, we know that is going to be given by the square root of dx d theta squared plus dy d theta squared d theta. So for our dx d theta, we're going to have just the derivative of cosine cubed, which is just going to give us a 3 cosine squared of theta, sine of theta, and a negative out in front. And likewise, for our dy d theta, we have the derivative of cosine squared of theta, sine of theta. And so that's going to give us a 2 cosine of theta times sine of theta with a negative times our second function, which is our sine of theta, plus our cosine squared of theta times the derivative of our second function, which is just cosine of theta. And so for our dy d theta, we're going to have a negative 2 cosine of theta times sine squared plus a cosine squared theta times cosine of theta. So if we take this and put it into our arc length form, let's see how that will simplify. So in our dx squared, dx d theta squared plus dy d theta squared, we can expand those terms, and let's see what we have. So it's going to give us a 9 cosine to the 4th of theta, sine squared of theta, plus, now when we expand our second set of parentheses, that's going to give us a 4 cosine squared theta sine to the 4th plus, or rather minus, a 4 cosine of theta sine squared of theta, and then our cosine cubed of theta, and then finally plus our cosine to the 6th of theta. Well, let's see how we can combine these now. So that's going to give us a 9 cosine to the 4th theta sine squared plus a 4 cosine squared sine to the 4th minus a 4 cosine to the 4th sine squared, and then plus a cosine to the 6th. Combining like terms, that's going to give us 9 cosine to the 4th sine squared minus 4 cosine to the 4th sine squared gives us 5 cosine to the 4th theta sine squared plus a 4 cosine squared sine to the 4th, and then plus our cosine to the 6th. Well, now what we can do, if we factor a cosine squared from each one of our terms, that will give us a 5 cosine squared theta sine squared plus a 4 sine to the 4th plus a cosine to the 4th theta. So that now a trick we can do is for our 4 sine to the 4th. So we have 5 cosine squared sine squared. For a 4 sine to the 4th, we can make it a 5 sine to the 4th minus a sine to the 4th, and then plus our cosine to the 4th. So what this does is, with our first two terms, we are then able to factor out a sine squared of theta, which will actually factor out a 5 sine squared theta, which will then just give us a cosine squared theta plus a sine squared theta. And then on the other side, we can group our cosine to the 4th theta minus sine to the 4th theta. So our cosine squared plus our sine squared, that one is just going to become 1. So we have a 5 sine squared theta. Then for our cosine to the 4th minus sine to the 4th, we can factor that as the difference of squares. So that we have a cosine squared minus a sine squared, and then a cosine squared plus sine squared. Well, the cosine squared plus sine squared gives us 1. And so what we're then left with is a cosine squared, a 5 sine squared theta, and then plus a cosine squared minus a sine squared theta. And so this will then simplify to a cosine squared theta. 5 sine squared minus sine squared gives us 4 sine squared, and then plus our cosine squared theta.